These are both phenotypic ratio and genotypic ratio, right? And we did few numericals also. But then now in this class we will continue with numericals. Okay. So first question is, these are the parents. Okay. Dihybrid cross parents, and number, the question is number of round dwarf in F2 generation is, okay, we have to find number of round dwarf. So this is round, this is F1 parents, right? Yeah. F1 parents are round, tall, wrinkle, dwarf. So here, when I take, it will be RT, and here it will be RT. So I'm crossing, we have this is small r, capital T, small t. Okay. This is the F1 generation का progeny. So when crossing between this only happens, then before gametes and now the four gametes. Right? So rather than writing that, just write the ratio. We know that phenotypic ratio for dihybrid crosses 9:1. Okay, so write that. And here we have round. We did one crossing now. The other traits we took and we did crossing. So reference to that, take round, first one's round will come and tall will come. Okay. And then after that round the dwarf will come, and then wrinkle down, and then wrinkle dwarf. Okay. So in this, the question is round dwarf. How many round dwarf obtained? Right. Round dwarf is 3. And our total offspring in every generation will be 16. Yes. Right. So we have 16 in the denominator and round dwarf is 3. So 3 by 16. Understood? And in the previous class I also told you how to find non-Mendelian cross and Mendelian cross difference. I don't know if you remember it or not. AA is one is dominant and one is into AA. This is Mendel. Right. So one parent will be completely dominant and the other will be completely recessive. Okay. So here, this is non-Mendelian. Right, because see here this is dominant. In Mendel's crossing it will be like that. It will not be like this. So this A and this one, these are the parents. They are asking us to find number of genotypes. When we cross this two and we get F1 generation, that F1 generation, this trait. How many offsprings will have this trait? Is what is the question. Okay. So first write this A and this one. This into this crossing. Okay. So A into A is capital A small, right? And this A into A is capital A small. postulates or laws. Okay, okay. We have two laws. Okay. One is law of dominance, and the other one is this is law of dominance and law of segregation. This has exceptions. Okay. So the exceptions are three. One is incomplete dominance. We'll read about it. What is incomplete dominance is when a red color flower and a white color flower is crossed. Okay. This is dominant and this is recessive. But when this is crossed, okay, it will produce pink color flower. Okay, so in this case blending happens. That is what it says, incomplete dominance. Okay, and codominance. Let's study about something called codominance, like ABO blood group will come. Okay, and multiple allonism also will study. Right? So based on dihydride cross, we proposed one that is law of independent assortment. Okay. So what law of dominance told is it gave the proportionality that we have that phenotype tall. This tall This was a monohybrid cross. These were the progenies. That is F2 generation was this. So we had 3:1 for phenotype, that is nothing but tau is to 1. Right. This was the ratio. So this ratio is based on law of dominance. Okay. So proportion of 3:1 is given by law of dominance. Right. And the second one is factors occurring pair. That's what the genes occurring pair. Right. Suppose if this is a chromosome and this is another chromosome, so this gene over here must have the same loci over here also, right? So that is what it occurs in pair all the time. So that is given by law of dominance again. And your characters are controlled by discrete units called factors. Genes are the ones which control our characters, right? Traits. Right? So that factors is genes. Now we have written genes. And expression of only one of the parental characters. See, when we crossed, this was his parents. Yes. Right. When gamete is capital T and your gamete is small p, and when he got the this, he got PT. Right. So what it says is expression of only one of the parental traits in monohybrid cross in F1 generation. This is F1 generation. Right? You understand? Yes. This is F1 generation. So in F1 generation, it resembles only one of its parents. That is, this is tall and this one also is tall. It didn't matter about the dwarf one or the recessive one. This was dominant, this was tall, so this was tall. Okay? Fine. So this thing is given by law of dominance. Okay? And the last thing is expression of both F2. Expression of both the parents in F2 generations. This is tall, this is tall, this is tall, and this is dwarf. Okay, the first parent which he took was tall and dwarf. So what we got in the F2 generation is also tall and dwarf. 3:1. Right? So these things are given by law of dominance. All these things. I put one here that we indicate that it is with reference to the first one. Okay. And this one is for second one. Okay. That is one is law of segregation. Law of segregation does not have any exceptions. Okay. Whereas law of dominance has 3 exceptions. Multiple allonism, codominance, and multiple allonism, codominance, and incomplete dominance. I explained that also, no? Okay. So this is law of segregation. Okay. What it says is alleles do not show any blending. Okay, there was no blending in monohybrid or dihybrid. So that is what it says. Alleles do not show any blending. Huh? There is blending. No. This is different case. We'll study about this. This is exception. Okay. Monozygous gametes are where both the traits are similar. Big round and round. This is monozygous and this is heterozygous. Right. So what they say is monozygous gametes produce similar traits in gametes. You see, this is monozygous. So this gamete will have similar. This R is similar to this and this. And here heterozygous, one produces two kinds of gametes each. Okay, it produces R and R. will be 3 is to 1. Right. So it is 3 is to 1. Fine. This is what independent assortment says. That is, see, when we take monohybrid also, the phenotypic ratio will be 3 is to 1 only. Okay, and when we take dihybrid cross, and we cross between two parents, and then we try to find out the phenotypic ratio, it will still be 3 is to 1 only. Okay, see, it's like when it was single, seed shape alone, when it was crossing. Okay, that time also it was 3 is to 1. Now when it is combining seed color, seed shape and seed color are combining, right? So when it is combining also, it will be same. Okay, it will not interfere. Okay, this will not interfere in its ratio, nor this will interfere in its ratio. Okay, yeah. So it's like there was an example in my board. A doctor gets married to a lawyer. Okay, so doctor won't go to the court and yeah. Okay, so doctor will not go to court and do the lawyer's work, nor will the lawyer come to hospital and treat patients. Right? So they both are different. They both are independent. Right? Even if they get married, no one is getting involved in each other's job. Okay, so it's like that. And it says, this is a very important point. Okay. See, we have chromosomes number here. This is present on 7, this is present on 1, 1, 4, 5, 4, 4. Right. So it works only on the autosomal genes that are present on different chromosomes. See, suppose when I take this and this does not work for that case. Okay. Law of independent assortment will not work for this case. Okay, because it is present on 1 and this is also present on 1. So it doesn't work for this. We can take this and this, we can take this and this, we can take this and this. Okay, but same chromosome number must not be there. Okay. Okay. Understood this part? Then we have something called as back cross. Okay. So I told you that there is something called as back cross. This is a PYQ topic. In back cross, this is nothing but crossing of progeny with parents. So usually what we used to do is to take parents and then whatever progeny we get, that progeny we used to keep it. Right? But here what we do is we cross the progeny whichever we get. In monohybrid cross, we get PT, PT and small t, right? So this one, we will cross this one with anyone. Our parents was capital T and small t, right? So we'll take any one of them, capital T or small t. Okay? So this is our progeny. cross and test cross. Okay, this is given in NCERT also. This is not given. Okay, this is given. It is highlighted, so it's a very important topic. Test cross. Okay. Do we know? This cross is usually done. Okay. Why is it done is to find the genotype of the dominant phenotype. What do you mean? What do you understand? To find the dominant. Oh, phenotype is a resultant of genotype. So, how does it even matter? See, to find a genotype. Genotype is something which we represent like this TT, right? So, to find the genotype of the dominant phenotype. Dominant phenotype is strong, obviously in this and this is dominant right now. So, to find if it is TT or capital T. Okay, we do this process. Understood? So, what we do is, in our progeny, we get small t also, right? So we do small t crossing with small t. Okay. So this is test cross. Test cross. I told recessive parent. Right. So this is recessive parent, and this is the phenotype whichever I got. I mean, genotype whichever I got in the F2 generation. Right. When we cross between this